So let us go through the example here. The one of the example is given. Define a linear transformation. The transformation is from R square to R square. That is, space is the dimension is same. So here transformation given is x1 and x2 are transformed to minus x2 and x1. You can see here the transformation matrix is 0, 1, minus 1, 0. What is this transformation? 90 degree rotation in the anti-clockwise direction, right? So find the images under T of u. That is, the vector has been rotated 90 degrees, and what will be the values or the images. So here u is given, v is given, and also you have to check for u plus v. Just you have to, what you have to do, multiply the x1, x2, takes the values of 0, 1 and 2, 3. So just multiply and check the values. So you can see here rotation matrix. After rotating vector 4, 1, it transformed to minus 1 and 4, and we have the transformation matrix. This is a rotation matrix. This is rotation matrix. 2, 3 is being transformed to minus 3, 2, and similarly you can apply it for u plus v. You can directly take u of u plus v given, or you can just add t of u plus t of v. That also gives you the, because the property holds good here. Instead of applying for added vector and then applying a transformation, you can add this plus this also. Both can be done here. So that is the way it is being rotated. This rotation can be explained here also. So you can have u was, what was the value of u? U was 4, 1 and v was 2, 3, and the addition will be 6 and 4. 4, 1, 2, 3. So you can see here 4, 1, u is being represented 4, and the height of this y is 1. This is your u. And another one was, what was the value here? It was 2, 3. So you can see here 2, 3, v is 2 times this height is 2 and this is 3, and u plus c is 6, 4. You can see this is 6 and this is your 4, and after transformation this vector is being rotated 90 degrees. If I am rotating it by 90 degrees, what is the values it is taking? So you can look at, if I am rotating it by 90 degrees, what are the values it is taking? Just you can write the values: minus 1, 4, minus 3, 2, minus 1, 4. You can see minus 1 here. That is, u is taking minus 1, 4, minus 1 and 4. This is your t of u. This is being shifted here by 90 degrees. And t of v minus 3, 2. So this is being shifted here, minus 3 and 2. Okay. And u plus v minus 4, 6. U plus v is being shifted here. You can see it is 4 and 6. So this value is 6. So it has been rotated 90 degrees. And here the 0 vector, if I am multiplying it with 0, 0, where it lies, the value will be 0, 0. So same it is lying on the points coordinates. Origin is maintained as it is. So this is the example of rotation. So the figure graphically you can check the values and even through the matrix. The next is reflection. What do you mean by reflection? When you are looking through a mirror, and how the images you look at. When we look at our mirror, what happens? Right side is shown as left and left is shown as right, right? So this is one way. That is when the mirror is placed in x-axis. When if I am placing it in the other way, it depends on where you are placing the mirror and through what direction you are looking into the mirror, right? So here you can have the image. You have to develop a matrix that tells you how the image is formed on the mirror. Image on the opposite side of a mirror, how it is formed. So let us take an example here. In this example, I am taking a 45 degrees line. We are illustrating with just one example. It can be any other points also. So I am having a mirror in the 45 degrees line, that is where y is equals to x. then that itself will be your 45 degrees line, this line. If it is 45, then automatically this whatever will be the value of x, that will be the value of y. So whatever that is, slope is equals to 1. So, and any point like 2 comma 2 is unchanged. So a point like 2 minus 2 is reverse to minus 2, 2. So 2 and 2 will be unchanged, and whereas a point like 2 and minus 2, what is the reverse of minus 2 and 2, and on a combination, if I have 2 plus 2 and 2 minus 2, that is, it becomes 4 comma 0. The matrix leaves one part. So here, if I am looking through a mirror, so what happens to 2 comma 2? It appears as left and right, that is, it appears 2 comma 2 itself. But if a point which is having 2 minus 2, if I am reversing that, it appears as minus 2 comma 2. So even I can represent them with a combination that 2 plus 2 and 2 minus 2, that becomes 4 comma 0. The matrix leaves one part and reverses the other part. You can see that is, one part has been reversed and the other part is kept as it is. So here you can have even the output of, if I am multiplying a with minus b, that is vector with b, I will be getting it 0 comma 4, that is 2 plus 2 and minus 2 plus 2, that is after reversing. So this was the original value, 2, that is, this is 2 comma 2, and these are the original values, and after transformation this value and this value, so that becomes what, 0, 4, and this is before transformation, it was 4, 0. So that is reflection at the 2 points. So here this can be, you can understand it better if I show you with an example. See, I am taking the same basis, the normal basis, that is your identity matrix. Always you have to consider this as the basic. You had, this was your values before applying any transformation, and after transformation what happens. So always if I look through the xy axis, it happens that 0 1 1 0 is when converted to 0 1 x and y, and y x, that is x y is being converted to y x, right? So here you can see this is a 45 degrees line. This is your vector, and if I am placing a mirror on the 45 degrees mirror, if I am placing a mirror at this point, what happens? X, Y is seen, if this is a mirror, this is seen as Y comma X. And you can have the mirror to be placed at this x-axis also, mirror can be placed at y-axis also, and here the example is shown as mirror placed at this axis. So whatever is appearing here will appear at this point automatically, and it becomes y comma x. So the transformation reflection matrix is represented by h, and it has h can be represented, that is, this is before transformation, and after transformation becomes 0 1 1 0. So the transformation matrix H becomes 0 1 1 0. This is an example for 45 degrees line, when the mirror is placed at 45 degrees. So you can have the matrix H can change, take the values when the mirror is placed on some other value, some other place. Okay. So I can briefly illustrate you